Yes. Yes, in the last class we discussed about the periodic table, in particular periodic property, that is electronegativity of an element. Electronegativity, that is En values, electronegativity values. Electronegativity value that depends upon the various factors. What are the various factors that affect the value of the electronegativity? In the last class we discussed about the first factor, that is atomic size. Atomic size. Atomic size. Whereas the atoms with smaller atomic size, they possess the higher value of the electronegativity. Therefore, atomic size and electronegativity. Smaller is the atomic size, higher is the electronegativity. Therefore, atomic size is inversely proportional to the electronegativity values. Atomic size is inversely proportional to the electronegativity values. Second one is that depends upon the Z effect. Whereas in Z effect, that is the ratio of the directly proportional to the positive charge and negative charge ratios. Whereas in the last class we discussed about the effective nuclear charge or that of the Z effect. Whenever the positive charge that increases, the electronegativity, that is a cationic size, that depends upon the cationic size, that is directly proportional to the electronegativity values. Therefore, the electronegativity is directly proportional to the Z effect. Z effect is directly proportional to the ratio of the positive charge to the negative charge, and it depends upon the hybridization value. Hybridization of central atom, whereas SP hybridized greater than that of the sp2 hybridized greater than that of the sp3 hybridized, especially in case of the hydrocarbons that you know. In case of the sp hybrid, the S character, that is S character, higher the S character, higher is the electronegativity. Higher is the S character, higher is the S character, higher is the electronegativity. Higher is the S character, higher is the electronegativity of an atom. Is it clear? Now it also depends upon, in the last class we discussed about all these things. Next one is oxidation state. There is a fourth factor, that is oxidation state. In that oxidation state, that is nothing but the charge carried by means of the cation or anion. For example, which one of the following is most electronegative? Whereas Fe or Fe2 plus or Fe3 plus, Fe2 plus or Fe3 plus, or Mn2 plus or Mn4 plus or Mn7 plus, because manganese possesses all the oxidation numbers. Whereas the O2 minus and O minus and O and also O plus. Now which one of the following that possesses the highest electronegativity values? Keep it in your mind, the atoms or the ions with the smaller size, they have ability to attract the shared electron towards it. Now what I mean by Fe, iron neutral atom, Fe2 plus, iron neutral atom that loses 2 electrons, means 2 positive charges are extra. Fe3 plus, that is a ferric iron or ferric ion, whereas the ferric ion is formed by the loss of 3 numbers of the electrons from the neutral atom. Therefore, the number of the positive charges are more and the number of negative charges are less. Try to understand. In the last class, I mentioned very important concept that with respect to the size of the cation and size of the anion. Cationic size is always smaller than the atomic size of the corresponding neutral atom. Anionic size is always larger than the atomic size of the corresponding neutral atom. Now, in case of Fe, no electrons are lost. Number of positive charges are equal to the number of negative charges. In Fe2 plus, 2 electrons are lost. What happens when 2 electrons are lost? 2 unit positive charges are more in the nucleus. Therefore, what happens in such cases? The number of electrons are less, number of protons are more. In such cases, the effective nuclear force of attraction between the nuclear charge and the remaining electrons in the higher energy level will be increases. Therefore, the higher energy level electrons that comes close to that of the nucleus, in the sense the shrinkage will occur. Therefore, ionic size will be very small. This implies that atomic size of the iron is larger compared to the ionic size of the Fe2 plus. Now, what do you mean by Fe3 plus? In case of the Fe3 plus, 3 electrons are lost by means of iron neutral atom. What does it mean? 3 unit positive charges are more in the nucleus compared to the total number of the electrons which surrounds the nucleus. Therefore, the nuclear force of attraction will be further increases due to the lesser number of the electrons. They have more affinity with that of the nucleus. Therefore, cationic size of the Fe3 plus is smaller than cationic size of the Fe2 plus, which is smaller than that compared to that of the atomic size. Therefore, size here corresponds to atomic size of iron. Atomic size of iron is greater than ionic size of Fe2 plus. Ionic size of Fe2 plus, which is higher than ionic size of Fe3 plus. Ionic size of Fe3 plus. Now, which is smaller one? Fe3 plus is very smaller one. Fe3 plus is very smaller one. According to our concept, whenever the size is very small, that is more electronegative. You know that atomic size or ionic size is directly proportional to electronegativity. Inversely proportional to the electronegativity. Whereas the smaller is the ionic size, higher will be the electronegativity. Therefore, according to this concept, whereas atomic size of iron is greater than ionic size of Fe2 plus, that is greater than ionic size of the Fe3 plus. This is with respect to the size, atomic or ionic size. Atomic or ionic size. Therefore, electronegativity values would be in the order. Fe3 plus is more electronegative compared to that of Fe2 plus, which is more electronegative compared to that of Fe. This is with respect to the electronegativity values of the ferric ion, ferrous ion and iron neutral atom. In your entrance exam, they will ask the questions like this. Either in atomic state they will ask, or in ionic state they will ask. In the ionic state, you should have the knowledge to predict the size. Higher the charge beared by means of the cation, positive charge beared by means of the cation, the ionic size will be very less. Such type of the ions are more electronegative in nature. Keep it in your mind. If any one of the cation of the same element which possess the higher positive charge over it, that possess smaller ionic size, that will be the more electronegative species. Is it clear? Now come to this topic. Manganese, manganese 2 plus, manganese 4 plus, manganese 7 plus. Now manganese 2 plus is obtained by manganese by the removal of the 2 electrons, because it acquires 2 positive charges extra, whereas Mn4 plus is obtained by means of losing 4 electrons from Mn or 2 electrons from Mn2 plus, and Mn7 plus is obtained by either by the loss of 7 electrons from Mn, or by the loss of 5 electrons from Mn2 plus, or by the loss of 3 electrons from Mn4 plus. Now tell me, which ionic size or atomic size is very small? Whenever the number of electrons are removing, then the attractive forces that gradually increases towards that of the nucleus, then the size will be minimum. Therefore, among all the species, Mn74 plus smaller ionic size compared to the Mn4 plus, compared to that of the Mn2 plus, and compared to that of the Mn. Now among these 4 species, which one of the following possesses smaller ionic size? Mn7 plus, that possesses smaller ionic size, and hence this is more electronegative in nature. In your entrance exam, they will give the options. Which one of the following is more electronegative? They may give first option is the Mn, second option is the Mn2 plus, third option is the Mn4 plus, fourth option is the Mn7 plus. Then identify which one of the following that possesses smaller ionic size, that ion that should possess higher value of the electronegativity. Is it clear? Yes. Now the atomic or ionic size in the order. Atomic or ionic size is in the order. Atomic or ionic size in the order. Atomic or ionic size, whereas Mn greater than Mn2 plus, that is greater than Mn4 plus, that is greater than Mn7 plus. That is atomic or ionic size. This implies that Mn7 plus has a smaller ionic size, has smaller ionic size. Mn7 plus has a smaller ionic size. Therefore, Mn7 plus is more electronegative. Mn7 plus is more electronegative. Mn7 plus is more electronegative. Therefore, we can arrange all them in the decreasing order of the electronegativity. Mn7 plus greater than Mn4 plus, that is greater than Mn2 plus, that is greater than Mn. This is in the order of electronegativity values. This is the order of electronegative values. Order of the electronegative values. Is it clear? Yes. Now come to this concept. Whereas it has all the species. Negative charge species are there, neutral species here, positive charge species is here. Now tell me, which one of the following possesses the highest value of the electronegativity among all the species? They may give an entrance exam. There is a O2 minus, and O minus, O and O plus. Now which possesses smaller ionic size? You know that the cationic size is always smaller compared to the anionic size. Cationic size is smaller. Cationic size. Cationic size is smaller. This implies that O plus size is smaller, anionic size is larger. Anionic size is larger. Anionic size is larger. Now based upon this, if the anions are two numbers, O2 minus and O minus. Among this O2 minus and O minus, which possess the higher ionic size and which possess the smaller ionic size? This implies that to the O minus, you need to add one more electron, then it will be converted into O2 minus. Therefore, whenever the number of electrons increases compared to the number of the protons, then the nuclear force of attraction between the nuclear charge and the remaining electrons will be increases, decreases. Therefore, the outer shell that slightly expands from the normal position. Whenever the electron number is greater than the proton number, expansion occurs. Whenever the electron number is smaller than that of the proton number, electron number is smaller than the proton number, shrink occurs. Then in such cases, cations are formed and hence the size will be decreased. Now it has 2 electrons extra, it has 1 electron extra, it has 1 electron shortage. This is the neutral atom. Is it clear? Now this, suppose it possesses 8 number of the electrons, it possesses 7 number of the electrons, it possesses 9 number of the electrons, it possesses 10 number of the electrons. Now whenever the electron number is less, then that ionic size is smaller. I will use shortcut method. Number of electrons, number of electrons. Number of electrons, O2 minus 10 electrons, O minus 9 electrons, O 8 electrons, O plus 7 electrons. Therefore, ionic size of O2 minus is greater than ionic size of O minus, greater than atomic size of oxygen, greater than ionic size of the O plus, ionic size of the O plus. This is with respect to atomic or ionic size, atomic or ionic size. Is it clear? Therefore, what about the value of the electronegativity? O plus has more electronegativity than O, which is more electronegative than O minus, which is more electronegative than O2 minus. This is with respect to the electronegativity values, electronegativity values. Therefore, among all these, they will give the entrance exam. Which one of the following that possesses the highest value of the electronegativity? Keep it in your mind. Positive charge species, they possess the highest value of the electronegativity compared to that of the negative charge species. That is shortcut method. If all are positive charges, then which one of the following that possesses the higher positive charge, that possesses the highest value of the electronegativity? Is it clear? Fine. Now this is about the electronegativity values and the basis of the oxidation number or oxidation state. Now, next one is Shoemaker's and Stephenson's law. Shoemaker's and Stephenson's law. See, by using this law, we can predict the bond length and stability, means in the form of the thermal stability of the molecules. Now, in case of suppose HCF, HF or HCl or HBr or HI is given. Now in case of the diatomic molecules are two types, homodiatomic molecules and heterodiatomic molecules. Whereas the homodiatomic molecules, like that of H2 is a homodiatomic molecule, whereas F2 is a homodiatomic molecule, Cl2 is a homodiatomic molecule, Br2 is a homodiatomic molecule, I2 is a homodiatomic molecule. Homodiatomic molecules means same types of the atoms repeats 2 times. Therefore, what about the nature of the bond here? Where is a H and H? The shared electrons are exactly at middle position of the 2 hydrogen atoms. What about F and F? The shared electrons are exactly at middle position of the 2 fluorine atoms. What about Cl2? Whereas the shared electrons are exactly middle position of the 2 chlorine atoms. In case of the Br2, the shared electrons are exactly at middle position of the 2 bromine atoms. In case of the I2, the shared electrons are exactly at middle position of the 2 iodine atoms. But in case of the HF, these are considered as heterodiatomic molecules. These type of the molecules are called heterodiatomic molecules. Diatomic molecules. These are homodiatomic molecules and heterodiatomic molecules. In heterodiatomic molecules, what about the bond length that is in between that of the H and F? It is decided by means of the electronegativity value of the electronegativity difference between the 2 atoms. Whereas you know that the fluorine is the most electronegative element and hydrogen is electropositive element because it falls in the S block of the modern periodic table. Fluorine falls in the P block of the modern periodic table, where the distance between the 2 that is given by means of the log D of AB. Distance between the AB that is given by means of one log, that is RA plus RB, RA plus RB, RA plus RB minus 0.9 into minus 0.9 into XA minus XB, XA minus XB, XA minus XB. This is very important formula. This law is called as a Shoemaker's and Stephenson's law. By using this, we can calculate there is a by means of this, in case of the heteromolecules, whenever the more electronegative atom is directly bonded to that of this hydrogen or any hydrides. Now, the decrease in the distance that is given by means of RA plus RB minus 0.9 into XA minus XB, whereas XA is given by means of electronegativity of element A and XP is given by means of electronegativity of element B, electronegativity of an element B. In entrance exam, they will give the RA values and RB values, or they may not given. That is homonuclear distance and between the A and B and that of the electronegativity difference between that of the 2 elements. Then you have to calculate the distance between these 2. Now suppose you have to solve one problem. You have to solve one problem. Now if the bond length of fluorine, bond length of fluorine, bond length of fluorine, bond length of fluorine is equal to 1.44 Armstrong unit, and bond length of hydrogen is equal to 0.74 Armstrong unit. Find out the bond length of HF. Find out the bond length of HF within bracket. Electronegativity of fluorine is equal to 4 units and electronegativity of hydrogen is equal to 2.1 units. Electronegativity of is equal to 2.1 units. Now this RF is given by means of RF plus RH, distance between hydrogen and fluorine, that is given by means of R of hydrogen plus R of fluorine plus 0.9 into, whereas electronegativity of fluorine minus electronegativity of hydrogen. electronegativity of hydrogen. RH is given by means of, it is a homonuclear distance. Therefore, RF is given by 1.44 divided by 2 and RH is given by means of 0.74 divided by 2. What about 1.44 divided by 2? That is, I think, 0.72 Armstrong unit. This is equal to 0.37 Armstrong unit. Now substitute these values. That is equal to 0.37 Armstrong unit plus, that is 0.72 Armstrong unit. 0.72 Armstrong unit plus 0.9 into, that is 4.0 minus 2.1. 4.0 minus 2.1. Now what about this value? The total value would be, now this is 0.37 plus 0.72, that is 0.37 plus 0.72, that is 1.09 plus 0.9 into, that is 4 minus 2.1, that is 1.9. What would be the value? That is 1.09 plus 1.9 into 0.9, that is equal to 1.71. Therefore, the total answer would be 1.09 plus 1.71, that is equal to 2.8 Armstrong unit. Therefore, distance between hydrogen and fluorine in hydrogen fluoride is equal to 2. This is equal to, this is minus, this is minus, this is minus. That is given by means of 0.09. This is 0.09. This is 0.71. This is 0.09 into 1.9. That is 0.171. Now this would be 1 minus 0.171. This is equal to 0.919 Armstrong units. 9.1 Armstrong units. Now recorrect this formula. This is not 0.09. This is 0.09. This is 0.09. Now this is the how to calculate the bond length between the two hetero atoms when they are bonded. Such type of the molecules are called heterodiatomic molecules. Now this is a very important formula in your entrance exam. They may give the RA value not directly. What about the values given? You have to divide it by 2. Home molecular distance is given, and electronegativity difference you have to calculate. Therefore, finally you have to calculate the distance between the hydrogen and that of the fluorine. Is it clear? Fine. Next one is, we can evaluate the acidic and basic strength. Acidic and basic strengths. It depends upon thermal stability. It depends upon thermal stability. It depends upon thermal stability. Now, assume that is a hydrates of 17th group. Hydrates of 17th group. That is hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. 17th group elements are fluorine, chlorine, bromine, and iodine. What do you mean by hydrides? The hydrides are the binary compounds of hydrogen with other element that should be more electronegative compared to that of the hydrogen. More electronegative elements like that of the fluorine, chlorine, bromine, and iodine, these are more electronegative compared to that of the hydrogen, and hence the binary compounds formed by means of hydrogen fluorine I will call it as a hydrogen fluoride, HCl, HBr, and HI. What about thermal stability? Thermal stability in the sense which one of the following is more stable molecule. If the difference in the electronegativity between this and this is very large, then those molecules are thermally more stable. If it is more electronegative, hydrogen is common one, then you have to predict the electronegativity of the remaining element. Hydrogen, there is fluorine, chlorine, bromine, and iodine. Among these, which one of the following is more electronegative? Fluorine is most electronegative. Therefore, HF molecule is more stable compared to HCl molecule, compared to HBr molecule, compared to that of the HI molecule. Therefore, thermal stability is in the order. Thermal stability is in the order. Thermal stability is in the order. What about the order? HF is greater than HCl, is greater than HBr, is greater than HI. Thermal stability is in the order. HF greater than HCl, greater than HBr, greater than HI. This implies that it is more stable. Hydrogen cannot be liberated, or hydrogen cannot be removed very easily. I will give a small beautiful example. You know that the lightweight iron box. In lightweight iron box, what about this polymeric materials? That is, you know that the Teflon material. In Teflon material, there is a bond between the carbon and fluorine. Whereas the carbon fluorine bond, it is very strong. Carbon fluorine bond, it is very strong. That is why even at high temperature, it will not broken into the segments. Or the Teflon material is thermally more stable. You know that this type of the materials are used in anti-sticking agents. Because of this property of the carbon and fluorine bond is very stronger, it is used in lightweight iron boxes. The reason is CF bond is very strong. Or not only CF bond, fluorine is most electronegative element. Therefore, whenever the fluorine has ability to form the chemical bond with that of the more electropositive elements, compared to this fluorine, the bond is very stronger. Such type of the molecules are considered as a thermally more stable molecules. Now, which is weaker? HI is weaker. If HI is weaker, then can we replace H in the form of the H in the form of the H plus? and I in the form of the I minus. We can dissociate very easily. This is possible if and only if HI is weaker. The covalent chemical bond between that of the HI is very weaker. Therefore, on heating it gives rise to H plus and I minus very easily. Since it has ability to give off the H plus very easily, then the molecule is considered as acidic in nature. Less thermally stable molecules. If the thermally more stable molecules, that does not undergo dissociation, whereas thermally unstable molecules, they undergoes dissociation very easily. Such type of the hydrates, they have the ability to give off the H plus ions very easily. You know that the concept, any chemical substance which has ability to give off the H plus ion is more acidic in nature. Therefore, proton donors are called acids. Proton donors. What about H plus? Hydrogen is the unique element. It does not contain the neutrons in the nucleus, but it contains only one proton and one electron. Whenever the electron is lost from that of the hydrogen, then we have only the protons in the nucleus. Therefore, proton donors are called acids, or H plus ion donors are called acids. Therefore, acidic strength that directly depends upon the acidic strength that depends upon thermal stability of the molecules. Therefore, thermal stability is in the order, and acidic strength is in the order. Acidic strength is in the order, whereas the HI greater than HBr, that is greater than HCl, that is greater than HF. Now, among HCl, HBr, HPA and I, which is more acidic in nature? HI is more acidic in nature. HI is more acidic in nature. HF is less acidic in nature. There is a relationship between thermal stability and acidic in nature. Thermal acidic nature is inversely proportional to the thermal stability. Acidic nature is inversely proportional to the thermal stability. Acidic nature is inversely proportional to the thermal stability of the molecule. Thermal stability of the molecule. Is it clear? This is very important hint. This is shortcut method. Whereas suppose in entrance exam, they will give the molecules like that of the HCl, HBr, HI and all these things, which one they arrange the following in the increasing order of thermal stability, or arrange the following the decreasing order of thermal stability, or which one the following is more acidic in nature, or which one the following is less acidic in nature. They may ask the questions. Keep it in your mind. The element which is more electronegative in nature, then the bond is very strong. Therefore, such type of the molecules are very stable molecules. Therefore, they are considered as a thermally more stable molecules. If the molecule is thermally more stable, then they does not undergo dissociation very easily. If the molecule is thermally unstable, this is possible if and only if the neighboring element is less electronegative in nature or more electropositive in nature. Therefore, among the fluorine, chlorine, bromine and iodine, last class I discussed, fluorine is most electronegative in nature, iodine is less electronegative in nature. Therefore, HI bond is weaker because of less electronegativity of the iodine. The HI molecule is thermally unstable. Therefore, on heating, the HI undergoes dissociation. Then it gives rise to the H plus ion very easily. You know that H plus ion donors are called acids. Therefore, HI shows acidic behavior. HI shows acidic behavior compared to HBr, HCl and HF. Am I right? Fine. This is very important. Acidic nature is inversely proportional to the thermal stability of the molecule. You know that in a 15th group of the modern periodic table, 15th group of the modern periodic table, we have nitrogen, that is first element, phosphorus, arsenic, antimony and bismuth. These are the elements present in 15th group of the modern periodic table. Is it clear? Like that of your 17th group of the modern periodic table, 17th group of the modern periodic table, we have fluorine, chlorine, bromine and iodine. First time, the last element, that is the radioactive element. Is it clear? Now the hydrates which are formed by means of hydrates of 15th group. Hydrates of 15th group. Hydrates of 15th group. What do you mean by hydrates? They are binary compounds of hydrogen with other element. Hydrates means binary compounds of hydrogen. Binary compounds of hydrogen. Binary compounds of hydrogen with other elements. Other element that should be more electronegative in nature. Other element that should be more electronegative in nature. Is it clear? What about the hydrates of this one? Ammonia, that is a hydrate of the nitrogen. PH3, phosphine, ASH3, SPH3, BiH3. These are considered as hydrates. Now, which one of the following is more stable? Little bit confusion. You compare the electronegativity values. When you compare the electronegativity values, electronegativity of nitrogen is greater than phosphorus, greater than arsenic, greater than antimony, greater than bismuth. This is about electronegativity values, because the top element is more electronegative in nature in a particular group. The top element is nitrogen, therefore nitrogen is more electronegative. Whenever the hydrates are there, thermal stability of the hydrates, Now, like that of the HF and HCl, HBr and HI, which is thermally more stable, HF is thermally more stable because next to the hydrogen, if it is a more electronegative element in the particular group, that element is that compound is thermally more stable. Therefore, thermally more stable, NH3 is thermally more stable than PH3, PH3 thermally more stable than ASH3, ASH3 thermally more stable than SBH3, SPH3 thermally more stable than BiH3. Is it clear? Whereas NH3 ammonia, PH3 is phosphine, and ASH3, SPH3, BiH3. Now these are the molecules we can arrange the decreasing order of the thermal stability. Now which one of the following is least stable molecule? BiH3 is the least stable molecule. Is it clear? Least stable molecule is thermally unstable or thermally least stable. Now in the previous case, see, HI is thermally unstable or thermally least stable, therefore it undergoes dissociation very easily. It has ability to give off the H plus ion, therefore I will consider the HI is more acidic in nature. Is it clear? Similarly here, which one of the thermally unstable or thermally least stable, that molecule is acidic in nature. Among ammonia, phosphine, ASH3, SPH3, BiH3, which is acidic in nature? BiH3 is acidic in nature. Now if BiH3 is acidic in nature, which is more basic in nature? More stable molecule, that is NH3, more stable molecule, that is NH3, more basic in nature. That is why ammonia is basic in nature. BiH3, bismuth trihydride, that is acidic in nature. Therefore, arrange the following: the decreasing order of the acidity or increasing order of the acidity. Therefore, with respect to acidic strength of the hydrates of the 15th group, whereas BiH3 is more acidic compared to SBH3 compared to ASH3 compared to PH3 compared to NH3 compared to NH3. I will give a small example. You know that of the ammonia. Ammonia is obtained by heating ammonium salts like ammonium chloride or ammonium sulfate, ammonium carbonate, whatever it may be, with the sodium hydroxide solution, caustic soda or sodium hydroxide solution. Take one hot glass test tube, add little bit ammonium salt like ammonium chloride, ammonium sulfate, ammonium carbonate, ammonium bicarbonate, whatever it may be. Add little bit sodium hydroxide solution. On heating strongly, it gives a full, that is a gas. That gas is ammonia gas. Sir, how can I check the ammonia gas? It gives a garlic smell. It gives a garlic smell. Or if you can take the red litmus paper and moisten it by putting in water, then the wet litmus paper, blue litmus paper is held to the fumes of the ammonia. The red litmus paper color that changes to blue color. That indicates that the liberated gas would be basic in nature. Therefore, ammonia is basic in nature. That is also true by using the explanation of the electronegativity values. Is it clear? Therefore, we can explain the nature. We can explain the acidic nature or basic nature or thermal stability or least stable molecules by using the electronegativity values. Is it clear? This is about the information that we can draw by means of electronegative values. Fine. Now, nature of the bonds. Nature of the bonds. Nature of the bonds. That is governed by means of Haney and Smith formula. Haney and Smith formula. According to this formula, ionic character is given by means of the formula. Ionic character is given by means of the formula 16 into Xa minus Xb plus 3.5 into Xa minus Xb whole square. This is where is the Xa is equal to electronegativity of A. Xa is equal to electronegativity of A. Electronegativity of A. Xp is equal to electronegativity of B. Electronegativity of B. Electronegativity of B. If the difference in the electronegativity, if Xa minus Xb value is greater than or equal to 2.1, if the difference in the electronegativity is greater than or equal to 2.1, molecule is ionic in nature. Molecule is ionic. Molecule is ionic. If Xa minus Xb is less than or equal to 2.1, then the molecule is covalence in nature. This molecule is covalence in nature. Is it clear? If the electronegativity difference between the HF is 2, calculate the percentage of the ionic character. For example, in formula problem, difference in the electronegativity, difference in the electronegativity, difference in the electronegativity between hydrogen and fluorine in HF is 2.0. Calculate the percentage of ionic character. Calculate the percentage of ionic character. Calculate the percentage of ionic character. You have to follow the formula. Formalize 16 into XA minus XB plus 3.5 into XA minus XB whole square. Now this is 16 into, this is 2.0 plus 3.5 into, that is 2 whole square. This is 32 plus 3.5 into 4, that is 14, that is 32 plus 14, that is equal to 46%. Therefore, the ionic character is 46%. If it is less than 50%, then that is a pure ionic in nature. If it is more than 50%, it is pure covalence in nature. Since it is less than 50%, therefore HF molecule we can predict it is a covalent bond compound, not ionic bond compound. Is it clear? This is about the properties that exhibited by means of the electronegativity values. Okay.